This is the video for lesson 4.1 class notes. Our bell work was this. If you would pause the video and write it down and attempt to do it. You will see that if you plug in 2 for n, only the 2 is the thing being squared. So we don't square a negative. The negative is not something being squared. So the 2 is going to be squared, which gives me 4. And of course I have to make it negative, and then I subtract 5 to give me a negative 9. The difference between this one and this other problem over here to the right is that the negative sign is inside the parentheses. If you have a negative n squared minus 5 and you plug in that 2, well, now the negative is also being squared. So now it's a positive 4 minus 5. All right, so this is lesson 4.1. We're identifying and graphing sequences. You can label this in your notes. This just goes in your notebook. There's a sequence, 7, 9, 11, 13. If you write that down, hopefully you can figure out what would be the next items in that sequence. So 7 is in the first position, right? What's in the second position? 9. What's in the third position? 11. The fourth position, 13. You could tell me what would be in the fifth position. Hopefully you know. We're adding here 2 each time, so that would be 15. You could also make a table. Please take a moment and copy that down. And let's make sure we can fill this in. So the first part of our table is really like the x, right? We call it the n in this case. The n is the position. We have to know that n is the position. All right, in the first position, we have 7. In the second position, we have 9. In the third position, we have 11. In the fourth position, we have 13. In the fifth position, we have 15. And then 17 would be in the sixth position. So n stands for position. F of n stands for the term that you're looking for. So we have to remember these. All right, this is on your note-taking guide. The first part of it says we have the explicit rule, f of n equals n squared plus 2. We want to know exactly what does n mean. Well, we learned that on the last page. N stands for the position. Well, what does f of 1 mean? And what does f of 2 mean, and so forth? Well, I told you f of n stands for the term, so if it's f of 1, it would be the first term. If it's f of 2, you would have the second term, and so forth. F of 3 would be the third term. If you get all the way down to f of n, well, that's just the nth term, right? If I plug in 4, it's the fourth term, the fifth term, the sixth term. Well, the n, f of n would be the nth term. Just the term in the nth position. So you would see in, if you watch the Math on the Spot videos, you notice that they label these a little bit differently. Instead of f of 1, they called it a sub 1. Okay, so this is just 2 different terminologies. Most of the time you're going to see it this way. Okay, you don't need to draw that, but I'm just showing you that's what we're talking about. So the second term would be a sub 2, and the nth term would be a sub n. Just 2 different terminologies. Our book uses the function notation. All right, number 1, write the first 4 terms of the sequence defined by the explicit rule here. Well, all we need to do is plug in our n, which is given to us. The first one is 1, so when I plug in 1 for n, well, I get 1 squared minus 5, which is 1 minus 5, which is negative 4. So the first term is negative 4. The second term would be to plug in 2, so 2 squared minus 5 gives us 4 minus 5, which is a negative 1. Now this is not on your notes, but if you want to write it somewhere you can. We could make a table where n, again, is the position. So what do we have in the first position? Well, that's our -4, right? N is the position, f of n is the term. What do we have in the second position? Well, that's a -1. Okay, you could keep going. So let's see. 3 squared minus 5 would be the third term. And 9 minus 5 is 4. And of course, 4 squared minus 5, 16 minus 5, which is 11. So if you wanted to finish that table, it would be the third term, the fourth term. Obviously, they go in order for n. N goes 1, 2, 3, 4, 5, and so on. And the terms are just these answers here. So we need a 4 and an 11. So they give us the position number. We need to find the term. Remember, f of 1 can also be labeled a sub 1, a sub 2, 3, and 4. All right, so if we find the 15th term using this sequence, this is called explicit. This is called the just plug it in rule. I can just plug in the number that they give me for the position. We're trying to find the 15th term, meaning the term that's in the 15th position. So I would just plug in 15 for n. Which is, let's see, 4 times 15 is 60, and 60 minus 3 is 57. Just plug it in rule. It's really nice. Okay, the recursive rule is a little bit different. As you read here, you need to know the previous term in order to find the next term. You can't just plug it in like we did with the last kind of rule. So look here at the example. So it says that f of 1 is 4. And then everything else, for any other term, we take the previous term and add 10 to it. So, n again stands for the position. F of 1 stands for the first term. F of n stands for the nth term. And this is the important one that you have to remember. F of n minus 1 stands for the previous term. Let's go back and look at this again. So it's telling me the first term is 4, and for any term after that, we take the previous term and add 10 to it. And this part here just means that works for anything greater than 1. Sometimes we write it like this too. Okay? Usually our book writes it that way. I don't care which way you write it. So for this example that we had in the beginning, this is not in your notes. All right, remember this one from the beginning where we had the first term is 7, second term was 9. Well, how would we write that? Well, we would give them the first term. We would say f of 1 is 7. And for any term after that, for any nth term, we take the previous term and just add 2 to it, right? So if I want f of 3, well, I have to know the previous term. You have to know what f of 2 is. F of 2 is 9. So if I take f of 2 and add 2 to it, I get 11. So it's just knowing the previous term. We'll talk more about this in the next lesson. But for now, let's just practice some of these. You're given a recursive rule. The recursive rule has this thing in it, exactly like that. If you don't see that, it's not recursive. In this one, we need to know the previous term in order to get the next term. They tell us what the first term is. So we already know that one. F of 1 is 35. And everything after that, I take the previous term and I subtract 2. So for f of 2, well, what was the previous term? It was 35. Well, I take 35 and I subtract 2. 35 minus 2 is 33. To get f of 3, subtract 2 again. I get 31. Subtract 2 again, 29. Subtract 2 again, 27. It's not bad, it's not hard, but you have to know the previous term in order to get the next one. Again, you don't have to write this down, I just want to show you if I wrote this as a table. Okay, our first 4 terms, right, that I gave you n, I'm finding f of n, right? So this was 35 I found, or I knew it, 33, and so forth, 31, 29, and then obviously the 5th term was 27. Okay, this is when we know n and we're finding f of n. Okay, let me explain what that means. All right, one more time. N stands for the position. You don't have to write this down, you're just watching. F of n, you know this from the beginning in our notes, it stands for the term. Well, if n is the position, then what's n minus 1? It's just the previous position. And if f of n is the term, then f of n minus 1 is the previous term. It's just one before it, right? Depending on what we're talking about. If it's just plain old n, we're talking about a position. If it's f of n something, it's talking about the term. All right, the first 5 terms for this recursive rule, and we know it's recursive because it has an f of n minus 1. So what am I going to do? I'm going to start with f of 1, which they give us. They told us f of 1 is 45. Every term after that, I take whatever the previous one is, and in this time, I subtract 4 from it. So I subtract 4 from 45. For f of 3, I have to take f of 2 and subtract 4, which would give me 37. Subtract 4 again. Subtract 4 again. Okay, you have to know the previous term to get the next one. It's not that hard. All right, number 5, we have an explicit rule for a sequence. So it's given the rule, and I give you one of the terms this time. Okay, this is a term, not a position. So back to our table, this is not on your sheet, but remember, before we used to be given these, and we had to find this one. Well, now we're given the position. So let me erase that. We're given a position. We don't know what position it's in. That's not the 4th position. It might be. But we don't know. We want to know the position that it's in. So what we can do is look at this. Obviously, it tells you it's an explicit rule. We know it's explicit because there's no f of n stuff, or excuse me, f of n minus 1. There is an f of n. There's no f of n minus 1. There is an n minus 1. That doesn't matter. So it's telling me that the term that I want is 51, negative 51. So I'm going to plug that in for the f of n. So this is actually f of n. I'm not plugging it in for n, I'm putting in for f of n. Okay? So here I can solve for n. I can distribute the negative 3. And then, of course, we're solving an equation because we're solving for n. We're going to subtract 3 from both sides. And then I'll divide by negative 3. If you get a negative number, you know something's wrong because we only have positive position numbers. So we know that negative 51 is in the 18th position. Okay. Same thing for this one. I want to find the position of this term. Okay, but this time it is a recursive rule, so we can't do anything unless we know the previous term. So the only way that you can't just plug it in this time. You can't just plug this in for f of n because this can't be touched. You can't take the n out of that. It doesn't work. So what do we know? Let's see. Well, we know the first term. Let's make a table. The first term, you can write this down. We know the first term because they gave it to us. So the second term would just be the previous term plus 0.2. So that would be 33.5. I'm just adding 0.2 to it. I would keep going until I get to 34.9. Because it's recursive, I can't just plug things in. I need to do them until I get up to that number. So it's a pain in the butt in that way. So I just keep adding 0.2. .1. Oops, not 2. 3. Whew. All right, we found it finally. So what position is this number in? It's in the 9th position. So the answer is the 9th position. All right, let's do another one. Same thing. We're given a sequence and we're given the term. We want to find the position. Is this one recursive? No, it's not. There's no f of n minus 1. So this one, you can just plug it in and go. All right, we're going to plug in 35 for f of n because that's the term. So I want the position, I want the n when f of n is 35. So solve the equation for n. Add 1 to both sides. As you can see, explicit rules are a little bit easier to work with, so we use them most of the time. All right, so just a little bit more practice with this to make sure we're all good. Definitely look and see and tell me if it's explicit or recursive. Explicit is the just plug it in rule. Recursive, you have to know the previous term. Right here, this thing here tells me it's the recursive rule. So I need to know the previous term. That's okay. I know the first term is 65,536. And what is it saying to do to the previous term? Well, the previous term looks like it's being square rooted. So if I square root 65,536, you can do that in your calculator. I'm plugging it in right now, 65536. I hit the square root button on my calculator. It looks like the square root of that is 256. All right, for the next one, I take the square root of that. All right, so in your calculator, you hit square root again. Square root of 256 is 16. All right, for the next one, I have to do the same thing, square root 16. Square root of 16, you should know, is 4. If you wanted to keep going, you could. You could square root 16 and so forth. That's all we did. We take the square root of the previous term. All right, this one, is it recursive? No, it's not. So I can just plug them in. I want to know the term for the position of 1, the first position, so I'm going to plug in 1 for n. Okay, to solve this, you do parentheses first. 1 minus 1 is 0. Of course, a half of 0 is still 0, and 0 plus 3 is 3. For f of 2, we have 1/2 times 2 minus 1 this time, which is a half of 1, which is just a half, and a half plus 3 is 3.5. And so forth. I'm not going to do more of those. I think you get that. You just plug in 3, you plug in 4. You can skip those ones. You don't have to finish those. Let's just make sure we understand. Let's do this one. Is it recursive or explicit? This one is recursive again because it has the f of n minus 1, so we have to know the previous term in order to get the next term. Okay, it's not the just plug it in rule. So the previous term, well, obviously the first term is 3, so we can write that down. And what are we doing to it? Well, it looks like I'm taking the previous term, and what am I doing to it? Well, I'm squaring it. So to get the second term, I take 3 and I square it. Okay, here's our second term. To get the third term, I take the second term and I square it. To get the fourth term, I take the third term and I square it. Have to know the previous term. Last part is just telling me if it's explicit or recursive. Remember, recursive is going to have the f of n minus 1 in it. So look at the first one. Does it have f of n minus 1? No. So this one is explicit. Second one. There it is. It's recursive. Number 3. Explicit. Number 4. There he is. Number 5. Explicit. And number 6. There he is again. Previous term. All right. So your homework, after you tape that into your note-taking guide, would be to do the rest of this. We just took the class notes, so you're good with number 1. You're going to do HRW and then the notes for the next lesson. There are 3 videos for these two together. 3 videos for homework.